Okay, here's another example of graphing polynomials, and we're going to factor, if we can, and we can in this case, and this is a nice situation where we got a nice fourth degree polynomial. We're going to be able to factor this, and we're going to find the zeros without having to find a rational zero by using synthetic division. So it saves a lot of time if you can handle something like this, if you can identify that it's a factoring method. I had a little kind of a misprint over here, so that's why I've kind of got some things already written down. But it's real easy to find when it's in this form, it's real easy to find the y-intercept when x is 0, y is 36, so that's easy. And the end behavior is easy. We always just look at the highest degree term. So that's going to be like y equals x to the fourth, which is positive even, which is just like y equals x squared. So it's going to be up and up. So that's my end behavior. Now we can take a look at this. Now this is like a trinomial, and we talked about this in class. This is like a trinomial in x squared rather than in x. In other words, a regular simple trinomial, x squared, x and a number, if you square the middle term, you get the first term. Well, if we square this middle term, we get the first term. So we can write this as like a simple trinomial, but only in x squared. That's going to be something like this. And x squared times x squared is x to the fourth. So we need two numbers to multiply to give 36. Now remember, since this sign is positive, this tells me that these signs are the same, and this tells me what they are, so they're both negative. We need numbers to multiply to give 36, and their sum is 13. And it looks like that would be what? 4 times 9 is 36, so that's going to work. So 4 times 9. Now just check this out by foiling out and see what we get. X squared times x squared is x to the fourth. Negative 9x squared and negative 14x squared is negative 13x squared. And negative 4 times negative 9 is positive 36, so it does work. Okay, but now we should notice that this is the difference of perfect squares. The square root of x squared is x, and the square root of 4 is 2. The square root of x squared is x, the square root of 9 is 3. So this is going to factor to be the product of the sum and difference of these little numbers. So y will equal the sum and difference. So this is going to be x plus 2 and x minus 2, and this is going to be x plus 3 and x minus 3. And now we've got it all factored out. We've got our 4 zeros. What are our 4 zeros going to be? X equals negative 2 plus 2, negative 3, and plus 3. All right, and then we have our intercept, we have our end behavior, so, and in this case they all cross. They're all exponents are 1. No even exponents, so just crosses, 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 crosses. So now we can graph it. So we can do this pretty fast. It's real easy if you can identify the factoring. So my intercept is at 36, so I'll give myself a little more room up in the front. Okay, there we go. A vertical line here. It's my y-axis, my x-axis, and then I've got, there's a little more room here. I'll try to use a ruler to make it nice and even. So I'm going to go 3 in each direction. 1, 2, 3. I will go 4. 1, 2, 3, 4. So this will be 2, negative 2, 3, negative 3. All right, and my intercept is going to be 36, so I'll make this 18 and make this 36, so it doesn't go too high. So I use a different scale for that. Put my zeros in. And my intercept. And my end behavior is like this, so it's going to be coming from here and going to there. And get out my pencil. So it's going to come down here. Yeah, see, that's why we use a pencil, so we can mess up a little bit. It's going to dip back, it's going to cross, and it's going to come up to the We talked about this in class. This is an even function because the powers are all even, so it's going to be symmetrical about the y-axis. So it's going to look just the same way on the other side. So I'll try to keep that in mind. And one of our more popular fourth degree equations is the W. It looks like a W there. So there you go. That's what these will look like when they're in this form, especially when we have a tricky one like that. Okay? So if that makes sense. So that's where you can really use that shortcut of identifying this as just another trinomial, but only a trinomial in x squared, not x.